So I'd like to welcome everybody that has just joined us to this session. This is the first IMS session of the GSE 2020 UK conference. So this will be on reaching the IMS database for an 8 gig line. Now what? And I'd like to say, first of all, that regarding any questions that you may have for this session, then Nick would like to have them fielded at the end. So you can actually put them on the chat channel if you like, or we prefer it actually if you verbally ask them at the end of the session. That would be great, but either is acceptable. Regarding introductions, well, our speaker, Nick Griffin, has been an IMS SME, especially on tools, but he's been working in the industry and certainly on the mainframe for well over 40 years. So without further ado, I'll hand you over to Nick, and thank you all for attending so far. Nick, over to you.
Well, thank you, Don. I'm glad to be here, and yeah, 40 years, or actually 45 this year. So been at it a while. I wish I was there. You know, it's kind of a shame we're not able to be in front of you like we always are, and I always enjoy being in the UK and at this conference. So hopefully next year we'll get the opportunity to get back and get involved and be part of the conference again. Yeah, this is a presentation I pulled together this year, and it kind of morphed from a lot of customer questions that I had. I kept getting these questions from customers, and they were experiencing problems with their database sizes, and then they were asking, well, you know, what should I do? I'm kind of down to just a few resources, and I really don't have the capability of getting applications to do anything for me. It's just a lot of things that were going on with our customers, and so I thought, well, you know, it's probably a good presentation to pull together and present for those type of customers. Now, I know this doesn't meet every customer need, and really this is a very high level presentation, but I kind of focused this toward the medium sized to small size customers. I realize you guys that are in big shops, you know, you've probably crossed this threshold before and said, okay, I've got a plan and I'm moving forward. But most of the medium and small size shops, you know, they just live day to day, and they're kind of, you know, thinking that their management's saying, well, IMS is going away in 5 years and don't do anything with it, or whatever. And it's been 20 years and it hadn't gone away yet, but you know, the database keeps growing and things keep happening, and so you know, that's kind of where I've focused this presentation around, and also I've kind of focused it in the direction of, I'm a full function database, and which in Europe, that's probably you know, 97-98% of the people. Just happens to be Dom happens to be one of the ones that has fast path, but for most of you are full function in some manner of IMS. So so it's really focused in that area as well. So hopefully it fits your needs, and it'll be something that you'll be able to get some information out of to help you down the road in the future. Let's see, move forward. All right, so here's just a quick glance at the agenda. You know, I'm going to discuss some of the issues that I see, and you know, and then some of the alternatives that I'm aware of, so we can kind of help you kind of work your way through those. So, is space the final frontier? Of course, I'm a Trekkie, like a lot of us are, but you know, when we talk about space here, I'm really talking about DASD or database space, but it really is true. It's you know, I kind of wonder if it's the final frontier. Do we have enough space? Can we get enough space? You know, I know some. In today's world, space is fairly cheap. We can go out and buy a DASD fairly cheaply, but what I've found is for our legacy systems, most customers are still not willing to go and just spend a lot of money on space. They just they don't do it. And like I said, for you medium and small size customers, it's probably very unlikely they're going to give you space. Most of the time, they're buying space for some big data project, and that's really what their goals are. So they don't look at the small legacy systems like us and try to spend money on us. So space is a very tough situation to get more of, and it's one of those things that it, you find a problem with, having enough space to move on. So I think probably this is probably not a surprise to everybody. It's it's just a list of what the data is generated in a single day, and I agree. It's not a mystery that most of this is things that are technologies today that are growing. That we see all the time, like tweets and emails and Facebook and things like that. And you think, well, man, all that stuff's growing, and it's really not affecting me, but even though it's outside of our legacy systems, data being generated in our legacy systems is still growing at a phenomenal rate. I mean, most all of us, even the mid-sized and small customers, I run into it all the time, that they may get an acquisition that they're not aware of, and all of a sudden their space is just going crazy, and they're trying to figure out, what do I do next? How am I going to resolve this? How am I going to get by the situation? So there are things in the world today that are going to cause you possible problems with data that's been generated. And I do think that bottom line down there just floors me when it says by 2025 we're going to have 463 exabytes of data. That's just amazing. I'm sure it's probably true. may even be more than that. Who knows? But that's a lot of data, and we'll see. We'll see how it kind of comes out. We only got 5 years to wait, so it won't take long to find that out. But it keeps growing. So I thought I'd bring up a couple examples. Here's an example of some data growth which happened mainly due to the coronavirus, and we saw this back in March, and it happened in the U.S. Both these examples are U.S. examples, but it was amazing. I mean, it just shows how people can overwhelm a system, based on their immediate demand. We had a whole bunch of banks that reported outages because, when this happened, everybody's kind of went crazy. They had to go buy up all the food they could get, and they needed cash, and they were, doing things in their accounts, and just the overwhelming increased volume was just totally messed up the banks and caused a lot of outages. And like we know, I mean, about 95% of all of our banks run on legacy systems, and then probably near the 90% mark, I think it's around 82 or 83, are IMS. So there's a lot of opportunity for failure if we get overwhelmed, and it can cause the systems to go down, like that was reported. And another issue that I saw during this crisis, which was a U.S. issue that happened in the New Jersey workman's comp system, which they end up running out of space due to increased new applications in their system. And for those of you that may not know what the U.S.-based workman comp system is, it's an unemployment system that when you get furloughed or dismissed, you can actually file for unemployment, and then you can get a certain amount of funds on a monthly basis as long as you're looking for work. And so it's been around for a very long time, just to help people stabilize until they get another job when they've been let go. And but the amazing part is, during this pandemic, we went from about 7% unemployment to well over 20%. So when you put that many people into the unemployment line, then they're all having to go into this system, and the systems are based on states, but in the U.S., but it's still, these systems were not designed to take that type and that amount of data, and so it just totally overwhelmed these systems. And one of the funny parts about this story was, in the article, it said, well, the way we need to fix this is we're gonna have to get some COBOL programmers that know IMS that can go out and help us resolve this issue. Well, when the state of New Jersey started looking for COBOL programmers, even with no IMS experience, they couldn't find any. Because I think, as we've seen over the recent years, people have been kind of converting off of COBOL, or even if they have, they've been narrowing down their staffs, and there just weren't that many people out there to do this type of work. But oddly enough, they put out a put out a big notice and said, hey, if you know COBOL, let us know. And they had a large group of people that came out of retirement and applied for these jobs and kind of took this up as a part-time job to help out the state and get this done. So they were able to get this resolved. But I thought it was a very interesting story how it all kind of progressed. But it also is an interesting story that it is the world today. The skills are diminishing, and we don't have as many skills and resources as we used to have. So like I said, I thought I'd kind of go over just a few basics on databases. I realize most of the people in this session are very knowledgeable of IMS, but maybe if you're not, you may have been kind of forced into the IMS world from outside areas. You may have been pulled in as a DB2 guy and your IMS guy left, and now you got to cover that too. So I want to kind of give just the very basics. And I'm not going real deep here, but just basics of database structures and information. So an IMS database, like most databases, consists of one or more data sets, and it allows IMS data to increase as free space decreases. So that's one of the things that you might run into a problem with. So once the primary space is used up and ends up out of space, then you have a condition that occurs, and that is that no secondary. That is if no secondary space was allocated. So when the secondary space allocation is specified, then the data sets will expand. But then they'll only expand to, where the data set is full. So once you run out you could run out extents. There's lots of other things that can cause condition fulls as well. And other problems is you could actually have not extents on data sets, but you could have run out extents on the volume. So I know extents have been increased, by a large number, but that doesn't mean anything, because even though you could have, 500 extents, you still only have a certain amount of space on a volume. So you could run out of space on a DASD, and then you're stuck as well. So there's lots of nuances to space that could cause you problems in a data set. And all of these, can be resolved in different ways. There may be ways you can reallocate and do things like that to get you out of that situation. But it's an outage. It's a problem. It's something you need to be watching for and planning for. So it's always there, and no matter what size of shop you are, that issue can still be there. They can always cause you problems. But the one that worries me the most, and should probably worry most of the middle to small size shops, is the IMS limits. IMS has a limit on database data, not the size of the data set, but actually the amount of data you can have within a data set. And it is limited to 4 gig for VSAM and 8 gig for OSAM. And when we reach that data size limit, then processing stops. The IMS will not go any further. It just stops, and you're dead in the water. For that application, that is. I mean, IMS itself will keep running, but your application is dead. You're in an outage situation, and you've got to do something. So this is just kind of a graphic, and I stole this information, but it's a graphic of what a database looks like. So when an IMS uses all this data for the first time, the IMS formats this into what's called control intervals or blocks, and these are allocated within the data set and can be used by IMS. The space that is formatted by IMS is the use space, and it's immediately available for IMS to utilize. Now, there are CIs, control intervals, and blocks that contain no data, which means that those are your free space. So you have an allocated area that has use space and free space, and that's all formatted with control intervals. And then the application can run and insert and replace operations and do those kind of things to take data in and out of your database. But your allocated space is what it is. So when the segments, when IMS stores segments into the free space, then he just keeps adding to this space till it gets up to the allocated space, and then he can increase that until he reaches the maximum amount. And that's where you end up with the max size, which we're talking about here. So what are your alternatives for actually fixing these type of problems? And so I've listed them out, and we'll just kind of go over these. These are the possibilities that you should probably consider. The possibilities here are like do nothing, change your full function database to HalDB or FastPath or PDF, or maybe implement compression. So let's kind of discuss each of those and kind of see where we're at here. So the first one I've got is do nothing, and let's be honest about this. I see it all the time, and I have to say I'm as guilty as anybody about procrastination. I couldn't even say it, but procrastination. It's a thing I do like everybody else does, and I'm probably all of us, are kind of the same boat. But there are probably a lot of ways that you can fix these problems, but I don't want to do anything unless there's just no other alternative. I mean, I'll sit and I was a DBA and I was a systems guy years ago, and I promise you, if I could get by without having to do anything and the problem would go away, that would happen. So when a ith occurred, we'd try to figure out, who else could fix this problem? Who could I assign this to? So it's not me having to deal with the issue. And we would, look at the applications and say, oh, okay, well, let's turn it over to applications and tell them, hey, your database is, running out of space. You got to go figure something out. And they could probably do a few things as long as it wasn't a total disastrous outage. Applications would probably, go in and take a look at it. But no one wants to have to resolve a problem in the middle of the night. I mean, that's the thing. You look at, when I was a systems programmer and a DBA, if I could do anything to keep from getting called after midnight, which seemed to happen a lot back in those days, it doesn't seem to happen. No, that probably does happen now, but it didn't seem to happen as much now as it used to. It's like every night when you're on call. But if you could do anything to keep that from happening, you would do it, right? So you get applications involved ahead of time. There's of course it says do it yourself, and I like to call that do IT yourself, because that's really what you end up having to do. Because usually the applications guys say, I don't know what to do. I don't know how. Surely you got a way to fix this problem. But there are ways you could do it. I mean, you could, go to the applications team and tell them, hey, you need to go out and archive or delete records. I mean, that's the way you can fix this. You can get rid of some of the data that's sitting out there. And so, some of the records, that you're looking at, they may be out there just for historical purposes. So maybe there's a way I can push them off and write an application and use them when needed, type of thing. But even then, maybe they're needed for audit reasons. Maybe they have to be there. There are places that they have like inventories that are sitting out there that you can't just get rid of the inventories, and you keep adding to the inventory and the database fills up. Well, if you get rid of inventory, how are you going to sell something, right? So there are issues you got to think about. And the other thing is, with this approach, it means someone has to take the time to make the decisions to figure out what needs to be archived and what needs to be deleted. And this is going to happen again. So it's going to happen on a regular basis. So somebody's got to spend the time to figure out what's going on here. And that's a resource that's just doing nothing but research. And that's a valuable resource that you're wasting time and money with. And the other thing is that really sustainable for a very long period of time? I mean, I think over time it could be very problematic. And if that guy happens to be on vacation and you run out of space, now what do you do? So do it yourself is probably okay, but it's one of those things you gotta think about a little bit. So let's talk about HalDB. HalDB, was introduced in IMS version 7 in 1997. It supports 1,001 partitions with up to 10 data sets per partition, which means it can get up to 40 plus terabytes of possible space. And it supports 4 gig for VSAM and 8 gig for OSAM for your partition sizes, right? So it's really available to help you. You know, the one thing I will note that is, you know, HowDB Online Reorg doesn't support or didn't support OSAM 8 gig. It may now, it hasn't been, but no matter what, you know, BMC and all the other vendors, you know, they have online reorgs that do support 4 and 8 gig, so that's not really a problem. But one of the key requirements to HowDB is that all partitions must be registered to DBRC. So that's one of the things you kind of have to think about is, you know, as you're adding this, because a lot of the mid-size and smaller customers, you know, they may not use DBRC. It always amazes me when I go around talking to customers and somebody says, "No, we don't have that turned on." And I'm thinking, "How do you recover?" So, well, we just go back to a backup. And I'm thinking you may have lost a lot of data in between that time frame. Are you worried about that? And I guess, you know, I guess they get by with it somehow or another. But and I also hear that, you know, people say, "Well, we hadn't had an outage in a year." Well, that's usually not a good excuse for auditors when you have an outage. So, so it's one of the things you got to think about. The DBRC should, I'm just saying DBRC should be turned on. That's just my philosophy. So, but anyway, so that's HowDB to start with. HowDB consists of you know, a master database and then a group of partitions. So you can see I got the segment name and I've got my fields, and so I can use this partition database utility to actually, you know, create this information and store it. You know, one of the things that you have to do is you have to set up keys. So you have your high keys for each petition. So they kind of go in order. You know, that's kind of the way it works. You have a petition and you have a high key, and so you have your data below that, and then you do the same thing for your next set of petitions, and this utility helps you kind of set that up and get that stored into the recon. So how that looks basically is, you know, you've got you go from what is like an HDAM database, which I've got 2 data sets assigned to it, and then I move that to HowDB database, which is now a PHDAM database, and I have multiple partitions. Well, to keep the same philosophy, then I would have the 2 data sets on each partition, and I would actually add another data set, which is your IDLS, and then I'd have all of that per partition. So this is kind of the graphic of what it would look like when you move from an HDAM to a PHDAM database. Sorry. So this is the migration process, and I'm going to come back to this in a second. But first, I want to talk about the number 1 item here, which is actually a migration tool. So I just believe everyone should utilize some type of migration tool. If you're going from full function to HowDB, you need to utilize a migration tool. Now, IBM has a PMR that's out there that's got a migration tool in it. It works great. Most of the other vendors have something as well, but these tools help you determine the optimum ranges for your record keys and the data that you're going to redistribute. So you can redistribute it evenly across your petitions or however you want to distribute it. It gives you some basics to get that done. And it helps you establish all these boundaries so you can generate the correct DBRC and IDCAM statements. These are things that you may not have thought about when you're actually going to go from HowDB or HDAM to FIDAM. You may not have thought about that, but those are very important things to kind of think about when you're building your new structures. And at BMC, we have a product which is called MaxDAM Database Advisor for IMS, which actually simplifies that with workflows. It's kind of like it does all the PMR work that IBM wrote, but we do it all in a workflow to kind of simplify walking you through that process to make it easier for someone that may not be as knowledgeable about IMS. They can just go pull up a PMR and say, "Oh, that's what I need to do." So we explain it as you go, and that makes it a little easier. So, but there are other tools out there as well to help you with those things. So this is not the only one. So back to the migration process. First you'll need to unload the full function database. Using a basic unload utility. Like I said, most all vendors have a utility of some sort you can do for unloads. And then you'll need to save the DBRC information using like the recon.backup command. This will be used in case you have to fall back. I mean, when you start these things like any other, you always got to look at what happens if I fail, right? So I gotta have a fallback of some sort. So recon.backup is a good way to do it. And I always say it's always good, no matter what you're doing, is to do an image copy before you start any change. No matter if it's just a schema change, just do an image copy right up front, right? So then you want to do, delete the full function database information, and you can do that using the delete.db command, which deletes all the information from the recon. The old database history, that'll be all obsolete now. Then you want to delete all the objects, that are related to that database. So like the DVDs and the MDA members, get rid of all that. You won't need that anymore. Then you'll define the HALDB by making the necessary DVD changes. So that's taking the DVD types, like we said, from maybe HDAM to either PHDAM or PHIDAM, or you'll also want to do the PS index. And then you'll define the HALDB to the recon. And you can do that by several ways. You can do it using a job, the DFS HALDB, or you can do the init commands, like the DBRC commands, like init.db or init.part. So the DBRC init commands can be used to find the HALDB easily. That's something you want to do. So the next thing you'll do is then you'll load the HALDB using another utility, an IMS utility, and that's just, like I said, it's a regular load like everybody's got. Then you'll run the index builds to build the indexes for your secondary indexes. And then finally, you'll take another image copy, because this is going to be your before and now your after of what you've done. And then you're successfully completed your DBRC authorization. So DBRC now knows the database is out there, it's been initialized, and it's got some history to it. So here are the differences in HALDB versus full function database, and I won't go over all of them, because some of these are no longer available. But if you need to share secondary indexes, those things are not available to you. Maybe if you have non-unique keys, that's something you have to think about. If you're using symbolic pointers or logical relationships that are virtual, that could be a problem as well. So those are things you need to take a look at before you start this whole process, before you look at doing any type of migrating. So the pros and cons are pretty simple. Naturally, the pros are I got to have more space, so storage space has increased dramatically. You have availability of a database on a single partition. So like it says, you can do reorgs on a single petition if you want to. Secondary indexes, indexes can be used. You can do a single partition to increase the size of a database if you want. So if you want to, take one partition and reorg it or change this size, you can do that without a problem. Some of the cons that you need to look at and think about, it does require application resources when you make this change. So it's not like you just go out as a DBA and make it happen. You need to coordinate this with applications. HALDB requires DBRC in every environment, even if it's test. So you have to figure out what's your implementation on test and how they're going to successfully make tests, do testing, and then rebuild testing. So that's a big deal that most people don't really put up front, but it's highly important, because that is, for most of us, test is production. It may not seem like it, but it is production. So HALDB does not support root only. You do have your PS index and your ILDS that are not recoverable. And then, it doesn't update the secondary index during the reload, so you'll have to rebuild those with some type of utility. So the next one I want to talk about is FastPath, and I won't spend a lot of time on this because I know most of you don't have FastPath, but it is a possibility. I think about FastPath as, it's not something that if I was going from a full function, I would consider it right up front. But if you have the right application, it's probably not a bad way to go. It's probably it would be a good situation to be able to move to FastPath, and it's a lot simpler. There's a lot of things you can get benefits out of by doing it. So it's a consideration. So I want to make sure and kind of cover it a little bit. I always like to say it's FastPath is exactly what it says. It's just a shorter path link to getting your work done, right? And that makes it faster. But FastPath was introduced back in IMS 1.1.4, and that seems almost incredibly long time ago, 1977. But it was actually, a request from financial institutions and others that needed a much faster transaction rate, and so that's why it was created. It just took a full function, and they cut the code paths as much as they could to make it as simple as possible, and it does simplify the type of data and segments you can do and everything, but it does make it much quicker. And I think, as you might have not, maybe you don't know, but maybe you do, but most banking institutions went to FastPath, and that's how you get your real quick ATMs, your real quick transactions to get things done. So FastPath supports 2,048 areas, which is about 8+ terabytes. I don't know if I think the PTF has already come out, but it may not have. I think it came out in 15.2, but it's going to 9,999 areas, which is greater than 40 terabytes. It's a huge amount of data. It supports, a max of 4 gig per area, and you'll note that instead of partitions, they're called areas, so it's a little different, but not much. One thing about FastPath, DBRC is not required, but like I said, that's my recommendation. Always turn DBRC on. Dangerous without. So always do that. And as it says, really, FastPath was also designed to be online all the time. That's really how it was really created. It was meant for, to be able to do online reorganization within it concurrently, and you can do that without an outage, unless you're trying to do a restructure, which is, basically trying to do a schema type change. So if you're needing to do a schema change, yeah, that can be a little bit of difference with FastPath, because most schema changes, you have to bring the whole FastPath database down. So all your areas have to come down, and that could be quite a long period of time. Now, there are a few vendors that now have restructuring type products, which can limit that to a matter of seconds or minutes, depending on how many areas you have. So you can do a structure change without, and you can do a structure change on an area also without having to do all areas. So there's lots of things you can now do that can minimize that amount of outage for availability purposes. So let me quickly go over these aspects of FastPath and how it achieves its high performance. First, the FastPath for DL1 calls, that FastPath length has been diminished, and it also significantly lowers the CPU. So you get a couple benefits out of this, right? You get things much faster, and your CPU is less. FastPath uses several techniques to reduce and eliminate I/O, so you have a lot less I/O. It has secondary dependent segments that are stored separately and from the roots, and that's for entry sequence manner to kind of at the end of the area. The SDEF facility is designed for data entry processing, which will give you a very fast insert capability. There's also high-speed sequential processing, which is designed to benefit the programs that do large volumes of physical sequential processing against these DEDBs. And I didn't explain this, but DEDBs is the same as FastPath. So it's it's data entry databases, but it's just it's kind of they're synonymous. So with high-speed sequential processing, you can benefit from read-only as well as update jobs. There's a subset pointer. The subset pointer creates a subset of the twin chain to enable applications to access the subset without having to process down the twin chain from the beginning. There's also a virtual storage option, which reduces I/O with decreased locking contention and creates more efficiency to write the area data set. They have main storage databases, which are not used as much, but this has no database I/O at all. Everything's they're rich segment databases, and they have a minimum amount of resource contention, so it makes it very fast. They reduce the path length, and only after image copy or any logs are done. So you've got less logging that's going to be happening. There's also an expedited message handler that has a dedicated buffer. So if you're doing a lot of terminal activity, you can speed up those fast path transactions. DDBs also have a randomizer routine that helps speed up your access to the data. Then stores data in specific areas, so you can keep your data separated in certain places. And as I said, the log reduction is greatly reduced during fast path organization. So it's operations. So it's these are all things that are just make fast path so much quicker and so much faster. So it's a good consideration. If you have an application that's capable of doing such. This is kind of a schematic of how FastPath is set up. When a DDB data set is initialized, additional control intervals are created for internal use, but the root addressable part is divided into different areas, one being your unit of work, which is better known as UOWs. But those are the basic elements of an allocation, a space allocation. Then you have your independent overflow, which contains a bunch of empty control intervals that can be used by your unit of work area. And then you have sequential dependence, which holds sequential dependent segments in the root area for all your unit of works in that area. So there's lots of backup places for data to be kept. And areas, to manage your fast path. So designing a fast path database, once you've decided to do it, you need to decide on what your segment distribution will be. This is important because it helps you calculate the average database record length. And this in turn helps you decide two things that you can't easily change once you create a FastPath database. And that's your control interval size and your unit of work size. So those are things you have to kind of think about well in advance. When you calculate the average database record length, you have to include the IMS overhead, which is a large number of bytes as well. All IMS data segments have a prefix that contain information IMS needs to know, but your application doesn't. So once you've picked a control interval size, then you must decide how many control intervals make a unit of work. And a unit of work has two parts, each comprising of a number of control intervals. The base part contains control intervals with a root anchor point. IMS uses the control intervals to store root segments and as many of their dependents as will fit in that unit of work. IMS stores secondary dependence segments in a different part of the data set. The dependent overflow parts contain control intervals that IMS uses when a base control interval runs out of space. So IMS assigns, one of the other dependent overflows control intervals to be the logical extension of the base control interval. I know this is kind of confusing, but there's a lot to it. But if another base control interval runs out of space, then IMS assigns it to a different dependent overflow control interval. Now you have to choose. Now that you've chosen your unit of work size, you're ready to decide on the size of the area. So you can allocate the space and units of work. You can say how many units of work you want to have, and there's 3 parts to this as well. You have to decide on how big your independent overflows to contain your pool of control intervals when in use, and then when they're exhausted, the dependent overflow control intervals have to also be decided. IMS assigns independent overflow control intervals to base control intervals on an individual basis. And if you fill up the entire individual and independent overflow part, there is a way to expand it, and it's a good idea to decide what to define this to DBRC as well. So you must initialize your database before you can use it, and you start off by deleting and defining the database. You can run a DBD gen, which the output suggests what your IDCAM parameters are. Then you run a DDB initialization utility. You take an image copy, and then you're ready to start your database area. So I know it's confusing. There's a lot to it, but control intervals and units of work, this is the basis of FastPath. So you kind of need to understand that before you move forward with FastPath itself. So when should you use a HalDB full function versus a DEDB? If there's no support for logical relationships in this, so you probably wouldn't want to use you wouldn't want to use FastPath. And secondary indexes are not really in FastPath. We've added them recently. There have been some vendor products that have been around for a long time that gave you secondary indexes, so you could have them, but it wasn't one of the original design. But they are available now. If your application needs to process root segments in a key sequence, you probably you will be able to use DDBs only if you can code the DDB randomizer to assign that root anchor point in that sequence. 64-bit buffers that have been removed. They've removed the restrictions, so there's not really much to worry about FastPath buffers anymore. Some databases have very short records and often only use record segments. And if you have such a database, you're probably going to run into some problems with DEDBs, so it might be something to consider. If you have a database with short records, IMS will seldom use the overflow part, so you're not really using all the effective database, and you'll be wasting a lot of database space. If you have a need for more than 127 segment types, you probably want to look at HalDB or full function and move in that direction. All DEDBs must be VSAM. And if for some reason you can't use VSAM, then another reason to go look at OSAM on HalDB or full function. So that's kind of an overview of FastPath. I know it's kind of quick, and sorry, a lot of data, a lot of information, but it's good to know. So you can go back and do more research in that direction. So the next area I want to cover is partitioning the partitioning option. In partitioning, there's a product that currently is called Partition Database Facility for IMS. It was actually delivered to the market back in 1997, and it was called IMS ESA Partition Support Product, which it was created by Neon for IBM. And IBM, this was IBM's first partitioning product that they came out with before they came out with HalDB. And once HalDB came out, they turned this product back over to Neon and allowed Neon to sell it. And that was kind of Neon's start and run. But after that, BMC bought Neon back in 2011, and we picked up that product. So there's a product that's available out there that's been around for quite a while. It supports 127 partitions, which is about 1+ terabytes, which is quite a bit of data. It includes support for high SAM, shy SAM, OSAM 8 gig. Like I said, DVRC is not required for this one, but it's highly recommended. And the really good thing about this one is there's really minimum to no application change. I've gone with several customers and they haven't had to do a thing, just add partitions and move on. So if you're running out of space, it's a very quick resolve, and that's really what it's about. The basic design, kind of like HalDB, you have a master database, and then you have partitions underneath that. And there's a part selection routine that you can use to register these to the recon. And like HalDB, you have a HDAM database, and you have one data set. Well, it can be an HDAM database with multiple partitions, and really the only thing you change is you just add the DBT statements to add those on, and you're kind of gone. You're ready to go. So it's a very simple process and very simple way to do things to get more data into your databases. So for PDF, basically you're just unloading the database, and of course naturally take an image copy ahead of time. But you add these part statements to your DVD, you run your gens, you notify DVRC if you're using DVRC, which I hope you are. And if you're using full function, you probably still have some MDA lives. You may want to update those with the new data set names. You load the partition database and build the indexes, do a final image copy, and alter any JCL that you have that you may be doing a reorg that would have one data set name. You want to have all your partitions in there as well. Outside of that, you're done. It's basically that simple. So it's a very easy way to move from a full database to having more space and without having to do any extra work. And that's really what partitioning is about. It significantly expands your database and distributes records across multiple partitions without you having to do anything. It's very transparent to your applications. And the good thing is there's really no, there's no performance hit. And matter of fact, in some cases we've seen where it actually improves performance because it can reduce contention because you've got everything in one spot. It just considers that those partitions an extension of the original database, and it improves your utility performance, and it allows for some parallel batch processing. So you can actually pick a partition and run batch against that particular partition if you want. So I've seen some customers that said, I've got, and this is in the States, but I've got a different partition for each country or something like that. And you can just, spread those out the way, however you want to. So it's very straightforward, and that's really what I like about it. It's just a simple way of doing an upgrade without all the risk and complexity and cost of having to go through some of the other migration directions. And the good thing is there's really no change to the procedures you've done before. Your procedures stay the same, so there's no real learning curve that you have to deal with. It's a simple operation. So the next thing I want to talk about, which is the last alternative, is talking about compression itself. And almost all your vendors have some means of compression capable products that are out there. And I'm sure you probably heard of them. If you haven't, then contact your vendor and learn a little bit about them, because it's a fairly simple way to do compression as well, or to increase space in your databases. So I actually had a customer, and this was actually this week. I was talking to them, and they got about 85% reduction in the space on using compression, which was just amazing to me. But they did it a couple of different ways, and there are many ways to do this. They used some XE routines and hardware to get that done. But it all depends on your segments. That's one thing I'll tell you on any type of compression. Compression can be fantastic. It can take a database and squeeze it down a lot, but it also depends on how your databases are built. So Some databases, we usually see somewhere in the neighborhood of 40 to 60% decrease in space size. So, when you think about it, if I can have a database that's full and I can get it down 40% less, and I've got that 40 cent to grow, it may have taken me 10 years or 15 years to get that 40% in there. So I may have another 10, 15 years of that database life without having to do anything else. And trust me, I'm a simple kind of guy and I don't like having to do a lot of extra work. That may be an easy out. Maybe an easy direction to go to make that happen. But there are some good things about doing compression. There's better buffer hit ratios. Your performance is improved. You got to remember, when I'm pulling in data, I'm actually pulling in a much larger block of data because it's compressed. It doesn't get decompressed till the IMS wants to read it, and then it's compressed before it's written back out. So you're pulling larger blocks of data, and there's really should be no application changes. I mean, the application shouldn't really see any problems here at all and shouldn't notice any differences. So compression is probably a good alternative to look at as well. One that I hope most people can do consideration with. We have a product that's called Data Packer for IMS. I mentioned it, but like I said, all other vendors have products. You can go look at their products as well. Ours has eight compression techniques, just a static Huffman and some hybrids and so forth. There's a number of different ways to do it. We have an IMS space management routine that helps you with space management. There are some other things you might want to look at, like minimum, if you have to do the minimum segment length or fixed pad size or free space segment size. Those are things you might have to look at when you're building your database. One of the things I like about what our product does is we have a trial utility, and within the trial utility, all you got to do is pull in about 20,000 records, and he'll tell you how much compression you would get on that database. Because like I said, databases are totally different, but based on how their segments are set up. Some databases you can get a lot, some you can't. But this trial utility, you can run it against different inputs like image copies, unloads, depending on expanded versions. But there are things you can run offline to find out how much compression you would get, which should help simplify your decision on whether it's worth doing or not. Implementation is fairly simple. You make a DBD change and add a compression routine parameter to your DBD segment names. I think all the vendors do kind of the same way. There's a different type for full function versus fast path, but you just kind of need to know what the data you're going to use, and so you'll have compress your data in the segments. There's a data statements you can use. There's also a knit statement you can use to force a knits. That way it automatically knits the database when the database is open. So Data Packer, is kind of like a PDF. It's pretty simple. Has doing compression or doing this partition database. Has a lot of benefits, and with Data Packer, it doesn't compress. It doesn't double compress. It tolerates non-compressed data if you want to have certain parts of data that aren't compressed. You can do segments just as is when they're inserted. So lots of benefits that you can do based upon these type of products. So I'm about done here. So which way do you go? I think, like we said, data is going to continue to grow. You're going to see it expand, and it's grown a lot in the last few years, and it's just going to continue to grow leaps and bounds. So you're going to run into these problems. You're going to start considering what I got to do and which direction I've got to go to get by that. So I'm hopefully I've helped you a little bit here and given you some information. But remember, all these depend on your time and resources that are available to get this done. And this is just a basic conclusion. Data is going to grow, and the good news is you've got some alternatives that'll help you just in case you run into that problem. The last thing I have on my presentation is, of course, naturally, I didn't come up with all this information on my own. You heard me read some stuff, some information, and I stole it from a lot of good books that people have written. There's a How to Be guide, there's a FastPath guide, there's a PDF data packer compression guide. There's also an IMS primer. So I've given you the links. If you want more detailed information, go out and grab these links, and you can read away. There's a lot of great information out there that people put out there that know a lot more about this than I do, trust me. But here's the information to help you. So thank you for joining. This is the QR code that you can use to submit your feedback, and I appreciate your time today, and hopefully you got something out of this that you can take away and look down the road. So Dom, I'll turn it back over to you.
Well, many thanks for that. Now, have we got any questions for Nick? I've asked everybody to unmute if they can. So if you want to ask a question verbally, then please do so now, and just unmute yourself when you ask the question. I've got a first question, actually, just to say that when we get a design for applications and we're trying to consider the data size for an application and for the design of a database, frequently we get the answer of well, we think the data is going to be this much, but we're not sure, and then it becomes quite a sort of a vague thing. So we've always been sort of quite pragmatic about this and trying to guess what the size of the actual size that something can grow to, because that will also drive what kind of solution some of the solutions you were talking about there.
That's true. And in your FastPath world, you know, it's if you don't have a good idea what the segment size is and how the database is going to be built, it's very difficult to figure out what that unit of work is going to be and what those control intervals and how you're going to do the independence or secondary dependence. That's tough. But I agree. One of the things that most applications people, they have no clue. They just know I'm building a database. Here's the segment size, and I don't know how many records are going to be in there. And you could automatically run into a problem when you start loading. That's your first time around. But like Dom said, you have to work with your application people. You need them to get this figured out. And hopefully, that's where some mid and small size shops run into problems. They don't have that resource or good resources that even know. Some of these databases were written 30 years, 40 years ago, right? So people that are here today may not even have a clue how it was written and why it was written. So it's a difficult task, and hopefully you can find an easy way to get by this.
Sure. So have we got any more questions for Nick? Hopefully verbally. I've got some feedback so far. Very interesting and very informative. Thank you, says Mike. So
glad to help.
Any more questions?
Hey, can you hear me?
Sure. Go ahead.
Yeah. So, which is the preferred way of getting more space without having application changes? I know the data compression, but most of the times we don't get more than 25% of space. So out of the methods you have described, so which one is the preferred way for getting more space without having application changes?
Yeah, that was that was why I was trying to explain about the data compression. Data compression is fantastic, but unless you have a specific type of segment, you can't compress it. I mean, you may not have blanks or zeros and so forth, so you can press it down. And if you only get 20%, that doesn't, or maybe 10%, that doesn't buy you anything. So the other three are probably your primary, but you know, of course, it's a BMC product now, PDF, but it's a very simple product to implement, and you can buy back without any application change. And sometimes we run into problems where you may have to do a little application change, but it's a very simple way of getting you some space and getting you by that problem. So we have you know, some easy utilities to make those things happen. But if you're going to do HowDB or FastPath, like I said, you got to get applications involved. You have no choice. So those are your considerations.
So the converting to HALDB, does it require application changes all the time?
It, yeah, I can't see how you could do without it, to be very honest with you. You're going to have to get applications involved, and that's a resource you're going to have to use.
And it's probably worth saying some of the code might need to change in terms of accepting particular return codes, that kind of thing.
Yeah,
because they are slightly different depending on which discipline you're in.
Thank you, Dom. That's right.
So we got any more questions for Nick? I'll take that as a no, because I don't think I've got anything on the chat channel as well. So can I just give a plug for, we have got 6 other IMS sessions, and they're all in the light green on the agenda. So feel free. This is the first one. We've got one tomorrow. We've got one's various days next week. So just a plug for the other IMS sessions that are out there. But thank you all for your attendance on this first session. I hope you found it informative, and with collective thank you to Nick from me on behalf of everybody. Thank you very much indeed for that. Much appreciated.
Anytime. Thank you, Dom.
So I'll end the session now, but thanks very much.
Thank you so much.